Asteroid belt is a unique part of the entire solar system. Do the asteroids of the asteroid belt settle somewhere else after leaving the belt? Yes, asteroids can leave the asteroid belt and go somewhere else. Jupiter's gravity can change the orbits of asteroids, sometimes knocking them out of the asteroid belt. Close encounters. Asteroids can be knocked out of the asteroid belt by close encounters with Mars or other objects. Collisions. Asteroids can crash into planets or moons. Ejected from the solar system, asteroids can be ejected from the solar system altogether. Asteroids that leave the asteroid belt can crash into planets or moons, be flung out of the solar system, alter the geological history of planets, impact the evolution of the life on Earth. Scientists monitor asteroids that cross Earth's orbit and near Earth asteroids that approach Earth's orbital distance. Radar is used to detect and monitor potential impact hazards. The orbits of asteroids can be changed by Jupiter's massive gravity and by occasional close encounters with Mars or other objects. These encounters can knock asteroids out of the main belt and hurl them into space in all directions across the orbits of the other planets. Asteroids fact, NASA Science, NASA Science.government, HTTPS science.nasa.government, Solar System, Asteroids fact. Asteroids, sometimes called minor planets, are rocky remnants left over from the formation of our solar system about 4.6 billion years ago. Introduction. Most asteroids can be found orbiting our Sun between Mars and Jupiter within the main asteroid belt. Asteroids range in size from Vesta, the largest asteroid at about 329 miles, 530 kilometers in diameter, to bodies that are less than 33 feet 10 meters across. The total mass of all the asteroids combined is less than that of Earth's moon. Sometimes asteroids and comets are nudged into Earth's neighborhood by the gravity of nearby planets. These objects are called near-Earth objects or NEOs. There are more than 35,000 NEOs according to the Center for Near-Earth Object Studies CNEOs at NASA's Jet Propulsion Laboratory JPL. About 99% of NEOs are asteroids. Their closest approach to the Sun is less than 1.3 times Earth's distance from the Sun. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his places up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. Trojan's arrow cut over the satellite. Someone who did not live with the sun. Kuiper belt is like the asteroid belt. Arrow is the hammer from there. Kuiper belt is like the asteroid belt. Arrow is the hammer from there. Trojan's arrow cut over satellite. Someone who did not leave the sun. Kuiper belt is like the asteroid belt. Arrow is the hammer from there. Kuiper belt is like the asteroid belt. Arrow is the hammer from there. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. Comets are included in the asteroid belt. Trained to raid anywhere. Meteors form clouds there. Unknown risks may rain down. Meteors form clouds there. Unknown risks may rain there. Comets are included in the asteroid belt. Trained to raid anywhere. Meteors form clouds there. Unknown risks may rain down. Meteors form clouds there. Unknown risks may rain down. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. Why is the asteroid named a minor planet? Asteroids are called minor planets because they are smaller than planets and are found in large numbers relative to the major planets. The two terms are often used interchangeably, but asteroid is more widely recognized. Asteroids are rocky, metallic or icy objects that orbit the Sun, primarily between the orbits of Mars and Jupiter. They range in the size from a few feet to thousands of miles in diameter. Asteroids were originally called planetoids, but the term was shortened to asteroids and meteoroids. The term planetoid is now used more generally to describe a small natural object with an elliptical orbit and no known significant planet. An asteroid is a minor planet, an object that is neither a true planet nor an identified comet that orbits within the inner solar system. They are rocky, metallic, or icy bodies with no atmosphere, classified as C type, carbonaceous, M type, metallic, or S type, silicaceous. Asteroids. NASA Science.Government, HTTPS Science.nasa.government, Solar System Asteroid. Overview. Asteroids, sometimes called minor planets, are rocky, airless remnants left over from the early formation of our solar system about 4.6 billion years ago. Most asteroids can be found orbiting the Sun between Mars and Jupiter within the main asteroid belt. Asteroids range in size from Vesta, the largest at about 3 to 9 miles, 530 kilometers in diameter, in bodies to bodies that are less than 33 feet 10 meters across. The total mass of all the asteroids combined is less than that of Earth's moon. Asteroid 2024 PTS on next close pass January 2025. Because 2024 PTS has a similar motion to Earth around the Sun, the asteroid will linger as a distant companion of our planet for a few months at a distance of about 9 times further away from Earth than the Moon. During this time, the object will never be captured by Earth's gravity. So while it's not quite a mini moon, 2024 PTS is an interesting object and NASA has plans to track it with planetary radar. By the way, how many bodies are there in the asteroid belt which are asteroids? How many bodies? A bunch of icy rocks in the belt, rotating around the sun. Rocky planets heads fly, rotating around the sun. Rocky planets heads fly. How many bodies? A bunch of icy rocks in the belt, rotating around the sun. Rocky planets heads fly, rotating around the sun. Rocky planets heads fly. It is said that this is the asteroid belt which is left of a Mars. An asteroid is a small or a big part. Venus may have been twisted after colliding. An asteroid is a small or big part. Venus may have been twisted after colliding. It is said that this is the asteroid belt which is left of Mars. An asteroid is a small or a big part. Venus may have been twisted after colliding. an asteroid is a small or big part. Venus may have twisted after colliding. How many bodies? A bunch of icy rocks in the belt, rotating around the sun. Rocky planets heads fly, rotating around the sun. Rocky planets heads fly. How many bodies? A bunch of icy rocks in the belt, rotation around the sun. Rocky planets heads fly, rotating around the sun. Rocky planets heads fly. Uranus has the same neon. Asteroids have so much power. There are many types of names. Trojans are dwarf satellites as well. There are many types of names. Trojans are dwarf satellites as well. Uranus has the same neon. Asteroids have so much power. There are many types of names. Trojans are dwarf satellites as well. There are many types of names. Trojans are dwarf satellites as well. How many bodies? A bunch of icy rocks in the belt, rotating around the sun. Rocky planets head fly, rotating around the sun. Rocky planets heads fly. How many bodies? A bunch of icy rocks in the belt, rotating around the sun. Rocky planets heads fly, rotating around the sun. Rocky planets heads fly. The asteroid belt where NASA's Dawn mission was made and was successful. The asteroid belt is a belt where there are many asteroids along with a large amount of meteorites and probably also comets. When was NASA's Dawn mission made there? NASA's Dawn mission launched on September 27, 2007 from Cape Canaveral, Florida. The mission spacecraft orbited two extraterrestrial bodies in the asteroid belt between Mars and Jupiter, Vesta, a giant asteroid. Ceres, a dwarf planet. Dawn was the first spacecraft to orbit two different extraterrestrial bodies. It entered orbit around Ceres on March 6, 2015. The mission operated until 2018. Dawn's mission was to learn more about these two worlds, which contain clues to how planets in our solar system form. The spacecraft's ion propulsion system allowed it to study the planets from different altitudes and vantage points. Dawn's data helped scientists understand the history and evolution of our solar system. Some of its discoveries include: Vesta has a layered structure like Earth, a substantial nickel iron core and a basalt surface. Ceres interior is stratified in a rocky mantle made of water-rich rock and an outer shell rich in water in the form of ice and hydrates. Dawn was launched September 27, 2007 and flew past Mars on February 17, 2009 to help reshape its trajectory toward the asteroid belt. Dawn arrived at Vesta on July 16, 2011 and orbited Vesta until September 5, 2012 when it left for Ceres 13 September 2024. Dawn, NASA.government, HTTPS science.nasa.government, mission Dawn. Both small worlds reside in the debris strewn main asteroid belt between Mars and Jupiter. Occurred 6 years ago. Dawn was NASA's first truly interplanetary spaceship. The mission featured extended stays at two very different extraterrestrial bodies, giant asteroid Vesta and dwarf planet Ceres. Both small worlds reside in the debris strewn main asteroid belt between Mars and Jupiter. Dawn was the first spacecraft to orbit two extraterrestrial destinations, the protoplanet Vesta and the dwarf planet Ceres, both in the asteroid belt beyond Mars. Mystery solved. Bright areas on Ceres come from salty water below. NASA's Dawn mission, honored by Space Foundation. How many bodies? A bunch of icy rocks in the belt, rotating around the sun. Rocky planets, heads fly, rotating around the sun. Rocky planets, heads fly. How many bodies? A bunch of icy rocks in the belt, rotating around the sun. Rocky planets, heads fly, rotating around the sun. Rocky planets, heads fly. It is said that this is the asteroid belt which is left of a Mars. An asteroid is a small or a big pearl. Venus may have been twisted after colliding. An asteroid is a small or big pearl. Venus may have been twisted after colliding. It is said that this is the asteroid belt which is left of Mars. An asteroid is a small or a big pearl. Venus may have been twisted after colliding. An asteroid is a small or big pearl. Venus may have twisted after colliding. How many bodies? A bunch of icy rocks in the belt, rotating around the sun. Rocky planets, heads fly, rotating around the sun. Rocky planets, heads fly. How many bodies? A bunch of icy rocks in the belt, rotation around the sun. Rocky planets, heads fly, rotating around the sun. Rocky planets, heads fly. Uranus has the same neon. Asteroid have so much power. There are many types of name. Trojans are dwarf satellites as well. There are many types of name. Trojans are dwarf satellites as well. Uranus has the same neon. Asteroids have so much power. There are many types of name. Trojans are dwarf satellites as well. There are many types of name. Trojans are dwarf satellites as well. How many bodies? A bunch of icy rocks in the belt, rotating around the sun. Rocky planets head fly, rotating around the sun. Rocky planets head fly. How many bodies? A bunch of icy rocks in the belt, rotating around the sun. Rocky planets heads fly, rotating around the sun. Rocky planets heads fly. How many bodies does that asteroid belt have? Where there are asteroids as well as comets. What is the difference between a comet and an asteroid? The main difference between asteroids and comets is their composition and where they formed in their solar system. Composition. Asteroids are made of rock and metal, while comets are made of ice, dust and rock. Formation. Asteroids formed closer to the sun where it was too warm for a ices to remain solid. Comets formed further from the sun where ices could stay solid. Here are some other differences between asteroids and comets. Appearance. When viewed in a telescope, asteroids appear as points of light, while comets appear fuzzy and or have a tail. Size. Asteroids range in size from small rubble piles to Ceres, a dwarf planet almost 1,000 km in diameter. Comets range in size from a few miles to tens of miles wide. Location. Most asteroids are found in the asteroid belt, a ring between the orbits of Mars and Jupiter. Orbit. The majority of asteroids in the asteroid belt follow stable orbits revolving in the same direction as the Earth. Comets are sometimes called dirty snowballs because they are often covered in dark dust. As the comets approach the sun, they lose material with each orbit because some of their ice melts and vaporizes to form a tail. Asteroids are made up of metals and rocky materials, while comets are made up of ice, dust and rocky materials. Both asteroids and comets were formed early in the history of the solar system, about 4.5 billion years ago. Asteroids formed much closer to the sun, where it was too warm for ices to remain solid. What is the difference between asteroids, comets and NASA.government? HTTPS www.nasa.government Directorates SMD. What's the 24 November 2021. What's the difference between asteroids, comets and meteors? These space rocks each have their own unique attributes, but differences aside, these fascinating objects are all worthy of study. Just ask NASA JPL scientist Ryan Park and you will agree. Well, they are all planetary objects orbiting the sun. An asteroid is a small rocky object and when seen in a telescope it appears as a point of light. Most asteroids are found in a ring between the orbit of Mars and Jupiter called the asteroid belt. Some asteroids are round, some are elongated and some even have a satellite. A comet also orbits the sun, but unlike an asteroid, it's composed of ice and dust. So when a comet gets close to the sun, its ice and dust content start to vaporize. So when seen in a telescope, a comet appears fuzzy and or has a tail. So what's a meteor? Well, let's start with a meteoroid. A meteoroid is a small piece of asteroid or a comet, typically pebble sized, but could be a little smaller or a little larger, and often created from a collision. When a meteoroid gets close to the earth and enters the earth's atmosphere, it's called a meteor. And a meteor enters the earth's atmosphere at a very high speed, so it burns up and produces a streak of light called a shooting star. So if you have seen a shooting star, you likely saw a meteor, and if a meteor survives the burn and lands on the ground, it's called a meteorite. So what's the difference between asteroids, comets and meteors? Well, asteroids are rocky, comets are icy, and meteors are much smaller and are the shooting stars that you see up in the sky. Learn more https go.nasa.government 3i4 to jpm. End video transcript, full episode list, full YouTube playlist. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his places up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. Trojan's arrow cut over the satellite. Someone who did not live with the sun. Kuiper belt is like the asteroid belt. Arrow cut is the hammer from there. Kuiper belt is like the asteroid belt. Arrow cut is the hammer from there. Trojan's arrow cut over satellite. Someone who did not leave the sun. Kuiper belt is like the asteroid belt. Arrow cut is the hammer from there. Kuiper belt is like the asteroid belt. Arrow cut is the hammer from there. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. Comets are included in the asteroid belt. Trained to raid anywhere. Meteors form clouds there. Unknown risks may rain down. Meteors form clouds there. Unknown risks may rain there. Comets are included in the asteroid belt. Train to raid anywhere. Meteors form clouds there. Unknown risks may rain down. Meteors form clouds there. Unknown risks may rain down. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. Can an asteroid become a comet? Yes, an asteroid can become a comet. Chiron, discovered in 1977, this large asteroid developed a coma and was given a double designation as a comet when it moved closer to the sun. Centaurus, these icy objects that have moved inside Neptune's orbit are similar to Chiron. Manx comets, these minor bodies have long period comet orbits but characteristics of inner solar system asteroids. Kuiper belt objects. These objects are thought to be mostly comet-like in composition, but some may be more like asteroids. The distinction between asteroids and comets is blurred by the discovery of these objects, and some say there is a continuum between the two. Asteroids are thought to have formed inside Jupiter's orbit, while comets are thought to have formed in the outer solar system. However, the discovery of these objects has shown that the distinction between the two is not always clear. Asteroid or meteor, what's the difference? NASA Space Place, NASA Science for Kids.government, HTTPS spaceplace.nasa.government, asteroid or meteor. An asteroid as a small rocky object that orbits the sun. A meteor is what happens when a small piece of an asteroid or comet called a meteoroid burns up upon entering Earth's atmosphere. Read on to find out more and learn the difference between asteroids and comets, meteorites and more. Asteroids. An asteroid is a small rocky body that orbits the sun. Asteroids are smaller than a planet, but they are larger than the pebble-sized objects we call meteoroids. Most asteroids in our solar system are found in the main asteroid belt, a region between Mars and Jupiter, but they can also hang out in other locations around the solar system. For example, some asteroids orbit the sun in a path that takes them near Earth. Meteoroids. Sometimes one asteroid can smash into another. This can cause small pieces of the asteroid to break off. These pieces are called meteoroids. Meteoroids can also come from comets, meteors. If a meteoroid comes close enough to Earth and enters Earth's atmosphere, it vaporizes and turns into a meteor, a streak of light in the sky. Because of their appearance, these streaks of light we are sometimes called shooting stars, but meteors are not actually stars because meteors leave streaks of light in the sky. They are sometimes confused with comets. However, these two things are very different. Comets orbit the sun like asteroids, but comets are made of ice and dust, not rock. As a comet's orbit takes it toward the sun, the ice and dust begin to vaporize. That vaporized with ice and dust become the comet's tail. You can see a comet even when it is very far from Earth. However, when you see a meteor, it's in our atmosphere. Meteorites. In fact, sometimes meteorites don't vaporize completely in the atmosphere. In fact, sometimes they survive their trip through Earth's atmosphere and land on the Earth's surface. When they land on Earth, they are called meteorites. NASA's Johnson Space Center has a collection of meteorites that have been collected from many different locations on Earth. The collection acts as a meteorite library for scientists. By studying different types of meteorites, scientists can learn more about asteroids, planets and other parts of our solar system. Because asteroids formed in the early days of our solar system, nearly 4.6 billion years ago, meteorites can give scientists information about what the solar system was like way back then. Related resource for education. Educators. Astronomicals, Astromaterials 3D, a virtual library for exploration and research of NASA space rock collections. Asteroid resource from NASA JPL Education. There is an asteroid belt all over the solar system after terrestrial planets like Mercury, Venus, Earth and Mars. Four planets are terrestrial: Mercury, Venus, Earth, Mars. Four planets are Jovian 2, power of Jupiter, Saturn, Uranus, Neptune. Four planets are Jovian 2, power of Jupiter, Saturn, Uranus, Neptune. Four planets are terrestrial: Mercury, Venus, Earth, Mars. Four planets are Jovian 2, power of Jupiter, Saturn, Uranus, Neptune. Four planets are Jovian 2, power of Jupiter, Saturn, Uranus, Neptune. Terrestrial here, Jovian there, a riot of asteroids in the middle. That is the asteroid belt. Interference between Jupiter and Mars. That is the asteroid belt. Interference between Jupiter and Mars. Terrestrial here, Jovian there, a riot of asteroid in the middle. That is the asteroid belt. Interference between Jupiter and Mars. That is the asteroid belt. Interference between Jupiter and Mars. Four planets are terrestrial: Mercury, Venus, Earth, Mars. Four planets are Jovian 2, power of Jupiter, Saturn, Uranus, Neptune. Four planets are Jovian 2, power of Jupiter, Saturn, Uranus, Neptune. Four planets are terrestrial: Mercury, Venus, Earth, Mars. Four planets are Jovian 2, power of Jupiter, Saturn, Uranus, Neptune. Four planets are Jovian 2, power of Jupiter, Saturn, Uranus, Neptune. Dwarf planets races in the belt. A big asteroid like Vesta is also there. Both are big in size. Vesta is actually 4 Vesta. Both are big in size. Vesta is actually 4 Vesta. Dwarf planets races in the belt. A big asteroid like Vesta is also there. Both are big in size. Vesta is actually 4 Vesta. Both are big in size. Vesta is actually 4 Vesta. Four planets are terrestrial: Mercury, Venus, Earth, Mars. Four planets are Jovian 2, power of Jupiter, Saturn, Uranus, Neptune. Four planets are Jovian 2, power of Jupiter, Saturn, Uranus, Neptune. Four planets are terrestrial: Mercury, Venus, Earth, Mars. Four planets are Jovian 2, power of Jupiter, Saturn, Uranus, Neptune. Four planets are Jovian 2, power of Jupiter, Saturn, Uranus, Neptune. There are two largest bodies in the asteroid belt. One is Ceres and the other is Vesta. Why is Vesta called 4 Vesta? 4 Vesta is the name of the second most massive asteroid in the solar system and the brightest asteroid visible from Earth. Size: 4 Vesta is almost spherical with a mean diameter of 525 kilometers, 326 miles. Mass: 4 Vesta is the second most massive object in the asteroid belt, accounting for about 9% of the total mass of all asteroids. Brightness: 4 Vesta is the brightest asteroid because of its size and unusually bright surface. In a dark location, it can sometimes be seen with the naked eye. Discovery: German astronomer Heinrich Wilhelm Max Weber discovered 4 Vesta on March 29, 1807. Name: Vesta is named after Vesta, the Roman goddess of home and hearth. Differentiated: unlike most asteroids, Vesta has a differentiated structure similar to Earth with a crust, mantle and core. Formation: Vesta formed early in the solar system within 1 to 2 million years of its birth. Dawn mission: NASA's Dawn spacecraft circled Vesta from 2011 to 2012 to study it. Vesta's most prominent feature is a large south polar basin that was likely formed by a massive impact. Vesta asteroid. Vesta is one of the largest objects in the asteroid belt with a mean diameter of 526 kilometers. It was discovered by the German astronomer Heinrich Wilhelm Matthias Albert on 29 March 1807 and is named after Vesta, the virgin goddess of home and hearth from Roman mythology. Wikipedia. Radius 262.7 kilometers. Mass 2.589 into 10 is to 20 kg. Spectral type V-type asteroid discovered 29 March 1807. Orbital period 1325 days. Gravity 0.22 m per square meter per second square. Discoverer Heinrich Wilhelm Matthias Alberts. Vesta. NASA Science.government. https science.nasa.government. Solar System Asteroid 4b. Overview: Vesta is the second most massive body in the main asteroid belt, accounting for almost 9% of the total mass of all asteroids. Discovered: Vesta was discovered at Bremen, Germany on March 29, 1807 by Heinrich Wilhelm Alberts, who had previously discovered Pallas. He proposed incorrectly, as it turned out that Ceres and Pallas were fragments of a destroyed planet, and found Vesta as the searched for more such objects. Vesta was the fourth asteroid ever to be discovered. How Vesta got its name? Four Vesta's discoverer Heinz Wilhelm Albert gave the honor of naming the new asteroid to German mathematician Carl Friedrich Gauss, who had computed its orbit. Gauss named it Vesta after the goddess of the earth and household in Roman mythology. Four planets are terrestrial: Mercury, Venus, Earth, Mars. Four planets are Jovian, two power of Jupiter, Saturn, Uranus, Neptune. Four planets are Jovian two. Power of Jupiter, Saturn, Uranus, Neptune. Four planets are terrestrial. Mercury, Venus, Earth, Mars. Four planets are Jovian two. Power of Jupiter, Saturn, Uranus, Neptune. Four planets are Jovian two. Power of Jupiter, Saturn, Uranus, Neptune. Terrestrial here, Jovian there. A riot of asteroids in the middle. That is the asteroid belt. Interference between Jupiter and Mars. That is the asteroid belt. Interference between Jupiter and Mars. Terrestrial here, Jovian there. A riot of asteroid in the middle. That is the asteroid belt. Interference between Jupiter and Mars. That is the asteroid belt. Interference between Jupiter and Mars. Four planets are terrestrial. Mercury, Venus, Earth, Mars. Four planets are Jovian two. Power of Jupiter, Saturn, Uranus, Neptune. Four planets are Jovian two. Power of Jupiter, Saturn, Uranus, Neptune. Four planets are terrestrial. Mercury, Venus, Earth, Mars. Four planets are Jovian two. Power of Jupiter, Saturn, Uranus, Neptune. Four planets are Jovian two. Power of Jupiter, Saturn, Uranus, Neptune. Dwarf planets races in the belt. A big asteroid like Vesta is also there. Both are big in size. Vesta is actually 4 Vesta. Both are big in size. Vesta is actually 4 Vesta. Dwarf planets races in the belt. A big asteroid like Vesta is also there. Both are big in size. Vesta is actually 4 Vesta. Both are big in size. Vesta is actually 4 Vesta. Four planets are terrestrial. Mercury, Venus, Earth, Mars. Four planets are Jovian two. Power of Jupiter, Saturn, Uranus, Neptune. Four planets are Jovian two. Power of Jupiter, Saturn, Uranus, Neptune. Four planets are terrestrial. Mercury, Venus, Earth, Mars. Four planets are Jovian two. Power of Jupiter, Saturn, Uranus, Neptune. Four planets are Jovian two. Power of Jupiter, Saturn, Uranus, Neptune. After Jupiter, Saturn, Uranus, Neptune, there is the Kuiper belt, which is a belt of the outer solar system. Right there, after Mercury, Venus, Earth, Mars, terrestrial planets, there is also the asteroid belt, which is a belt of the inner solar system. Why are these belts formed? Pressure belt, also known as atmospheric circulation cells, are formed on Earth due to the uneven heating of the planet's surface by the sun and the rotation of the earth. The distribution of solar energy and the earth's rotation create distinct zones of atmospheric pressure that encircle the planet. These belts play a key role in shaping global weather patterns and the movement of air masses. Here are some of the pressure belts on Earth. Equatorial low pressure belt, also known as the doldrums. This belt is located near the equator and is characterized by low atmosphere pressure. The intense solar heating in this region causes warm air to rise, creating a low pressure zone. Subtropical high pressure belts located at about 30 degree north and south of the equatorial. This is an area of high pressure where ascending equatorial air currents descend circumpolar low pressure belts located between 60 degree and 70 degree in each hemisphere. Polar high pressure areas located at the north and south poles between 70 degree to 90 degree north and south. The cold descending air gives rise to high pressures over the poles. These belts are formed due to solar radiations, uneven heating to the Earth's surface. The thermally induced pressure belts are further divided into the two types: equatorial low pressure belts, polar high pressure belts. 4 August 2023. What are the Van Allen belts and why do they matter? NASA Science.government, https science.nasa.government. Biological physical stories preparing for future missions to the moon and Mars. Exploration gives us the sense that anything is possible. Exploration leads to knowledge and understanding and means that you make the world a better place as you explore. People have always tried to leave the world a better place for future generations. Unknown, exploring beyond the Van Allen belts. One of the largest hazards for astronauts traveling to Mars will be overcoming exposure to high energy radiation from the solar wind, solar storms and galactic cosmic rays that originate outside of our solar system. This radiation is more damaging to humans than medical x-rays used to see broken bones or treat cancer. The Earth's magnetosphere traps the high energy radiation particles and shields the Earth from the solar storms and the constantly streaming solar wind that can damage technology as well as people living on Earth. These trapped particles from two belts of radiation known as the Van Allen belts that surround the Earth like enormous donuts. One, the outer belt is made up of billions of high energy particles that originate from the sun, and the inner belt result from interactions of cosmic rays with Earth's atmosphere. Astronauts must fly through the Van Allen belts to reach outer space, so it is important to fly through this region quickly to limit their exposure to radiation. Sensitive electronics on satellites and spacecraft traveling through the Van Allen belts also need to be protected from the radiation. Discovered in the 1950s, located beyond low Earth orbit, these radiation belts were discovered in 1958 by astrophysicist James Van Allen, who helped uncover the key to enabling exploration of the outer solar system. Van Allen calculated that it was possible to fly through the weaker regions of radiation to reach outer space. In 1968, NASA's Apollo mission 8 was the first crewed spaceship to fly beyond the Van Allen belts to orbit the moon and then return to Earth. The most recent time humans have set foot on the moon or traveled beyond low Earth orbit was in 1972 during the final mission of the Apollo program, Apollo 17. When the International Space Station was completed in 2011, its low Earth orbit made it safer for astronauts to travel to and from the station as it is a shorter distance from Earth. Approximately 250 miles, roughly the distance between Washington DC and New York City. Going further with Artemis, NASA plans to use its upcoming Artemis missions to send astronauts beyond the Van Allen belts to land on the south pole of the moon by the end of 2025 and eventually onto Mars. Since a one-way trip to Mars could take 6 to 9 months, it is important to first develop technologies and conduct research on the moon to better understand what is needed to thrive in deep space. Since the moon is more accessible to us than Mars, scientists can use it to gain important scientific knowledge about the effects of the harsh conditions of deep space on living systems. Altered gravity, high energy, radiation exposure and different atmospheric composition are just a few of the unique stresses that can affect our ability to sustain life of Earth. The Artemis 1 mission was an important step towards understanding the impacts to life beyond the Van Allen belts by flying model organisms around the moon and back. This research could help identify which crops to grow on the moon, alternative sources of fuel, and how to ensure crew health during long periods of exposure to the harsh conditions of space beyond the protective layers of the Van Allen belt. Related information around the moon and back, a test drive for science studying the Van Allen belts 60 years after America's first spacecraft, radiation belts, fun facts, citations, 1 HTTPS www.nasa.government mission pages RBSP mission fun facts HTML. The inner ring of with the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his places up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. Trojans arrow का दो अर्थ satellite. Someone who did not live with the sun. Kuiper belt is like the asteroid belt. Arrow is the hammer from there. Kuiper belt is like the asteroid belt. Arrow is the hammer from there. Frozen arrow का दो अर्थ satellite. Someone who did not leave the sun. Kuiper belt is like the asteroid belt. Arrow is the hammer from there. Kuiper belt is like the asteroid belt. Arrow is the hammer from there. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. Comets are included in the asteroid belt. Trained to raid anywhere. Meteors form clouds there. Unknown risks may rain down. Meteors form clouds there. Unknown risks may rain there. Comets are included in the asteroid belt. Trained to raid anywhere. Meteors form clouds there. Unknown risks may rain down. Meteors form clouds there. Unknown risks may rain down. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. Why did the asteroid belt form only after the terrestrial planets? The asteroid belt formed after the terrestrial planets because the region of the solar nebula where it is located didn't have enough material to form a planet. Not enough material, the region didn't have enough material to form a planet. Temperature. The temperature was just right to prevent rock from stacking together. Too much rocky material. There was too much rocky material to form a terrestrial planet, but not enough gaseous material to form a Jovian planet. The asteroid belt is made up of material that was never able to form into a planet, or if the remains of a planet that broke apart a very long time ago. The asteroids in the belt come in a variety of sizes from very small to quite large. The asteroid belt separates the four inner rocky planets from the four outer gas planets. The presence of Jupiter as the fifth planet is believed to be the reason that the asteroid belt formed. Formation and evolution of the solar system. Wikipedia, https en.wikipedia.organization, wiki, formation and evolution. The evolution of the asteroid belt after late heavy bombardment was mainly governed by collisions. Asteroid belt. The outer edge of the terrestrial region between 2 and 4 AU from the Sun is called the asteroid belt. The asteroid belt initially contained more than enough matter to form 2 to 3 Earth-like planets, and indeed a large number of planetesimals formed there, as with the terrestrial planetesimals in this region later coalesced and formed 20 to 30 moon to Mars-sized planetary embryos. However, the proximity of Jupiter meant that after this planet formed 3 million years after the Sun, the region's history changed dramatically. Orbital resonance with Jupiter and Saturn are particularly strong in the asteroid belt, and gravitational interactions with more major embryos scattered many planetesimals into those resonances. Jupiter's gravity increased the velocity of objects within this resonance, causing them to shatter upon collision with other bodies rather than accrete. As Jupiter migrated inward following its formation, see planetary migration below, resonance would have swept across the asteroid belt, dynamically exciting the region's population and increasing their velocities relative to each other. The cumulative action of the resonance and the embryos either scattered the planetesimals away from the asteroid belt or excited their orbital inclinations and eccentricities. Some of those massive embryos too were ejected by Jupiter, while others may have migrated to the inner solar system and played a role in the final accretion of the terrestrial planets. During this primary depletion period, the effects of the giant planets and planetary embryos left the asteroid belt with a total mass equivalent to less than 1% that of the Earth. Composed mainly of small planetesimals, this is still 10 to 20 times more than the current mass in the main belt, which is now about 0.0005 ME. A secondary depletion period that brought the asteroid belt down close to its present mass is thought to have followed when Jupiter and Saturn entered a temporary 2:1 orbital resonance. See below. The inner solar system's period of giant impacts probably played a role in Earth acquiring its current water content, 6 into 1021 kg. From the early asteroid belt, water is too volatile to have been present or Earth's formation and must have been subsequently delivered from outer colder parts of the solar system. The water was probably delivered by planetary embryos and small planet smells thrown out of the asteroid belt by Jupiter. A population of main belt comets discovered in 2006 has also been suggested as a possible source for Earth's water. In contrast, comets from the Kuiper belt or further regions delivered not more than about 6% of Earth's water. The panspermia hypothesis holds that life itself may have been deposited on Earth in this way, although this idea is not widely accepted. The belts, both the asteroid belt and the Kuiper belt, are wonders of the solar system. There are two belts here, a miracle of the solar system. One is the Kuiper belt, the other belt is the jewel of asteroids. One is the Kuiper belt, the other belt is the jewel of asteroids. There are two belts here, a miracle of the solar system. One is the Kuiper belt, the other belt is the jewel of asteroids. One is the Kuiper belt, the other belt is the jewel of asteroids. The name is the space asteroid belt, where the asteroid's home is. There are countless small ones. There are many big stones. There are countless small ones. There are many big stones. The name is the asteroid belt, where the asteroid's home is. There are countless small ones. There are many big stones. There are countless small ones. There are many big stones. There are two belts here, a miracle of the solar system. One is the Kuiper belt, the other belt is the jewel of asteroids. One is the Kuiper belt, the other belt is the jewel of asteroids. There are two belts here, a miracle of the solar system. One is the Kuiper belt, the other belt is the jewel of asteroids. One is the Kuiper belt, the other belt is the jewel of asteroids. The asteroid belt is thin, where there is also plenty of space. It passes through easily. Spacecrafts go far and wide without colliding. It passes through easily. Spacecrafts go far and wide without colliding. The asteroid belt is thin, where there is also plenty of space. It passes through easily. Spacecrafts go far and wide without colliding. It passes through easily. Spacecrafts go far and wide without colliding. There are two belts here, a miracle of the solar system. One is the Kuiper belt, the other belt is the jewel of asteroids. One is the Kuiper belt, the other belt is the jewel of asteroids. There are two belts here, a miracle of the solar system. One is the Kuiper belt, the other belt is the jewel of asteroids. One is the Kuiper belt, the other belt is the jewel of asteroids. NASA's Dawn mission explored Vesta and Ceres in the asteroid belt, but many NASA spacecraft have easily crossed the asteroid belt and reached the outer solar system. But why has no NASA spacecraft collided with an asteroid in the asteroid belt? NASA spacecraft have not collided with asteroids in the asteroid belt because the asteroid belt is mostly empty space and the asteroids are thinly distributed. Space is big and empty. The asteroid belt contains millions of asteroids, but the space between there is vast. Asteroids are thinly distributed. The asteroid material is so spread out that spacecraft can pass through without incident. Natural collisions are rare. NASA estimates that two asteroids in the asteroid belt collide naturally only once every 10 million years. Spacecraft like Voyager 1 and 2 have safely passed through the asteroid belt. NASA has also conducted a mission to intentionally move an asteroid to test how to protect Earth from future collisions. DART mission. The double asteroid reduction test. DART. Spacecraft deliberately collided with an asteroid to deflect it and slightly change its path. The DART mission was the first time humanity intentionally moved a celestial object. NASA DART mission hits asteroids in first ever planetary NASA.government, HTTPS www.nasa.government, news release, NASA's DART mission 27 September 2022. After 10 months flying in space, NASA's double asteroid redirection test DART, the world's first planetary defense technology demonstration, successfully impacted its asteroid target on Monday. The agency's first attempt to move an asteroid in space mission control at the Johns Hopkins Applied Physics Laboratory APL in Laurel, Maryland announced the space successful impact at 7:14 p.m. EDT. As a part of NASA's overall planetary defense strategy, DART's impact with the asteroid Dimorphos demonstrates a viable mitigation technique for protecting the planet from an Earth-bound asteroid or comet. If one were discovered at its core, that represents an unprecedented success for planetary defense. But it is also a mission of unity with a real benefit for all humanity, said NASA Administrator Bill Nelson. As NASA studies the cosmos and our home planet, we are also working to protect that home, and this international collaboration turned science fiction into science fact, demonstrating one way to protect Earth. DART targeted the asteroid Moonlight Demon Dimorphos, a small body just 530 feet, 160 meters in diameter. It orbits a larger 2560 foot, 780 meter asteroid called Didymos. Neither asteroid poses a threat to Earth. The mission's one-way trip confirmed NASA can successfully navigate a spacecraft to intentionally collide with an asteroid to deflect it, a technique known as kinetic impact. The investigations team will now observe Dimorphos using ground-based telescopes to confirm that DART's impact altered the asteroid's orbit around Didymos. Researchers expect the impact to shorten Dimorphos' orbit by about 1% or roughly 10 minutes. Precisely measuring how much the asteroid was deflected is one of the primary purpose of the full-scale test. Planetary defense is a globally unifying effort that affects everyone living on Earth, said Thomas Jurbuchen, Associate Administrator for the Science Mission Directorate at NASA headquarters in Washington. Now we know we can aim a spacecraft with the precision needed to impact even a small body in space. Just a small change in its speed is all we need to make a significant difference in the path an asteroid travels. The spacecraft's sole instrument, the Didymos Reconnaissance and Asteroid Camera for Optical Navigation DRACO, together with a sophisticated guidance, navigation and control system that works in tandem with small body maneuvering autonomous real-time navigation. Smart nav algorithms enable DART to identify and distinguish between the two asteroids targeting the smaller body. This system guided the 1260 pound 570 kilograms box-shaped spacecraft through the final 56,000 miles 90,000 kilometers of space into Dimorphos, intentionally crashing into it at roughly 14,000 miles 22,530 kilometers per hour to slightly slow the asteroid's orbital speed. DRACO's final images obtained by the spacecraft seconds before impact revealed the surface of Dimorphos in close-up detail. 15 days before impact, Stars CubeSat companion light, Italian CubeSat for imaging of asteroid, Lycia Cube provided by the Italian Space Agency, deployed from the spacecraft to capture images of stars impact and of the asteroids resulting cloud of ejected matter in tandem with the image returned by Draco. Lycia Cube's images are intended to provide a view of the collisions effects to help researchers better characterize the effectiveness of kinetic impact in deflecting an asteroid because Lycia Cube does not carry a large antenna. Images will be downlinked to Earth one by one in the coming weeks. DART's success provides a significant addition to the essential toolbox we must have to protect Earth from a devastating impact by an asteroid, said Lindley Johnson, NASA's planetary defense officer. This demonstrates we are no longer powerless to prevent this type of natural disaster, coupled with enhanced capabilities to accelerate finding the remaining hazardous asteroid population by our next planetary defense mission. The Near Earth Object (NEO) surveyor, a DART successor, could provide what we need to save the day. With the asteroid part paired within 7 million miles, 11 million kilometers of Earth, a global team is using dozens of telescopes stationed around the world and in space to observe the asteroid system. Over the coming weeks, they will characterize the ejecta products produced and precisely measure dimorphous orbital change to determine how effectively DART detected the asteroid. The result will help validate and improve scientific computer models critical to predicting the effectiveness of this technique as a reliable method for asteroid deflection. This first of its kind mission required incredible preparation and precision, and the team exceeded expectations on all counts, said APL Director Ralph Semler. Beyond the truly exciting success of the technology demonstration, capabilities based on DART could one day be used to change the course of an asteroid to protect our planet and preserve life on Earth as we know it. Roughly 4 years from now, The European Space Agency HERA project will conduct detailed surveys of both Dimorphos and Didymos with a particular focus on the crater left by Dart's collision and a precise measurement of Dimorphos mass. John Hopkins APL manages the DART mission for NASA's Planetary Defense Coordination Office as project of the agency's Planetary Missions Program Office. To see the final images before DART's impact visit, https go nasa.government 3 rare RER1 NW. For more information about DART, visit https www.nasa.government DART. In Joe's Handle Headquarters, Washington 202-358-2307. Joshua A. Handle NASA.government. Justina Suroi Mikhail Bukle. Johns Hopkins Applied Physics Laboratory 240-302-9268 240-228-7536. Justina Suroer Wapel.edu. Mikhail Bakle Wapel.edu. Is NASA really crashing a spacecraft into an asteroid? NASA.government. https www.nasa.government. Solar system. Is NASA really crash 17 November 2021? Yes, NASA really is crashing a spacecraft into an asteroid. That spacecraft is DART, the Double Asteroid Redirection Test. There are two belts here, a miracle of the solar system. One is the Kuiper belt, the other belt is the jewel of asteroids. One is the Kuiper belt, the other belt is the jewel of asteroids. There are two belts here, a miracle of the solar system. One is the Kuiper belt, the other belt is the jewel of asteroids. One is the Kuiper belt, the other belt is the jewel of asteroids. The name is the space asteroid belt, where the asteroid's home is. There are countless small ones, there are many big stones. There are countless small ones, there are many big stones. The name is the asteroid belt, where the asteroid's home is. There are countless small ones, there are many big stones. There are countless small ones, there are many big stones. There are two belts here, a miracle of the solar system. One is the Kuiper belt, the other belt is the jewel of asteroids. One is the Kuiper belt, the other belt is the jewel of asteroids. There are two belts here, a miracle of the solar system. One is the Kuiper belt, the other belt is the jewel of asteroids. One is the Kuiper belt, the other belt is the jewel of asteroids. The asteroid belt is thin, where there is also plenty of space. It passes through easily. Spacecrafts go far and wide without colliding. It passes through easily. Spacecrafts go far and wide without colliding. The asteroid belt is thin, where there is also plenty of space. It passes through easily. Spacecrafts go far and wide without colliding. It passes through easily. Spacecrafts go far and wide without colliding. There are two belts in here, a miracle of the solar system. One is the Kuiper belt, the other belt is the jewel of asteroids. One is the Kuiper belt, the other belt is the jewel of asteroids. There are two belts here, a miracle of the solar system. One is the Kuiper belt, the other belt is the jewel of asteroids. One is the Kuiper belt, the other belt is the jewel of asteroids. The two wonders of the solar system are the asteroid belt and the Kuiper belt. Is the miraculous asteroid belt the remains of a planet, or did two planets keep forming and become the asteroid belt? No, the asteroid belt is made up of leftover material from the solar system's formation that never came together into a planet. Formation. The asteroid belt formed from planetesimal, which are smaller precursor to protoplanets. Disruption. Jupiter's gravity disrupted the planetesimal's accretion into a planet, causing them to collide and shatter. Loss of mass. In the first 100 million years of the solar system history, the asteroid belt lost 99.9% of its original mass. The asteroid belt is located between Mars and Jupiter and separates the inner rocky planets from the outer gas planet. The belt contains millions of smaller asteroids. An estimated 1.1 to 1.9 million asteroids larger than 1 kilometer in diameter. Asteroids of several types, including C-type, S-type and M-type. The asteroid belt is slowly eroding through collisions. For example, NASA Hubble observation showed an X-shaped debris field that was likely the result of a head-on collision between two asteroids. Asteroids fact. NASA science.government, HTTPS science.nasa.government, solar system asteroid fact. Most asteroids can be found orbiting our sun between Mars and Jupiter within the main asteroid belt. Tracking evolution in the asteroid belt. NASA science.government, HTTPS science.nasa.government, science highlights. Asteroids don't just slam into planets like Jupiter or Earth, they also collide with each other. Astronomers using Hubble witnessed one such impact in the asteroid belt, an area between Mars and Jupiter that holds the rubble leftover from the construction of our solar system. Hubble observations showed a bizarre X-shaped pattern of fragmentary structure near the point-like core of an object with trailing streamers of dust. This complex structure suggested their small body was the product of a head-on collision between the two asteroids traveling 5 times faster than a rifle bullet. These observations help support the idea that the asteroid belt is slowly eroding through collision. Asteroid or comet. Another Hubble observation of the asteroid belt revealed an unusual object, an asteroid with 6 comet-like tails of dust radiating from it like spokes on a wheel. Unlike all other known asteroids which appear simply as teeny points of light, this asteroid resembles a rotating lawn sprinkler. Computer models of the object suggest that the tails may have formed through a series of dust ejection events. A binary asteroid. Hubble also observed the first known binary asteroid that also looks like a comet. The pair orbits each other and has a tail or dust like a comet. The asteroid called 300163 2006 BW139 likely broke into two pieces some 5000 years ago due to its fast rotation. The asteroid was discovered by Space Watch in November 2006. Then Pan stars observed its comet-like activity in November 2011. Both Space Watch and Pan stars are asteroid survey projects of NASA's Near Earth Object Observation Program. After the Pan stars observations, it was also given a comet designation of 288b. This makes the object the first known binary asteroid that is also classified as a main belt corner comet. A fragmented asteroid. Hubble also watched the slow breakup of asteroid P by 2013 R3 into 10 smaller pieces. The Hubble data showed that the fragments are drifting away from each other at a leisurely 1 mile per hour, slower than the speed of strolling human, which suggests the breakup is not the result of a collision. The inner ring of with the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his places up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. Trojans arrow over the satellite. Someone who did not live with the sun. Kuiper belt is like the asteroid belt. Arrokoth is the hammer from there. Kuiper belt is like the asteroid belt. Arrokoth is the hammer from there. Frozen Arrokoth over satellite. Someone who did not leave the sun. Kuiper belt is like the asteroid belt. Arrokoth is the hammer from there. Kuiper belt is like the asteroid belt. Arrokoth is the hammer from there. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. Comets are included in the asteroid belt. Trained to raid anywhere. Meteors form clouds there. Unknown risks may rain down. Meteors form clouds there. Unknown risks may rain there. Comets are included in the asteroid belt. Trained to raid anywhere. Meteors form clouds there. Unknown risks may rain down. Meteors form clouds there. Unknown risks may rain down. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. Did Forbesta stop short of becoming a full-fledged planet in the asteroid belt? Yes, Forbesta in the asteroid belt stopped becoming a full-fledged planet because Jupiter's gravity disrupted its growth. Exploration. Vesta was likely still accumulating material to become a full-sized planet when Jupiter's gravity stopped its growth. Jupiter's gravitational pull disrupted the formation of Vesta and other objects in the area. Significant. Vesta is the only known remaining rocky protoplanet from the early days of the solar system. It's a time capsule from that era with a surface that may be the oldest planetary surface in the solar system. Features. Vesta is the second largest asteroid with a diameter of 330 miles. It's also the brightest asteroid visible from Earth. Exploration. NASA's Dawn spacecraft orbited Vesta for 1 year from July 2011 to September 2012. The data collected by Dawn helped researchers learn more about Vesta's formation and history. For Vesta, NASA Science.Government, HTTPS Science.NASA.Government, Solar System Asteroid for Vesta. Overview. Vesta is the second most massive body in the main asteroid belt, accounting for almost 9% of the total mass of all asteroids. Only dwarf planet Ceres is more massive in that region of rocky debris between Mars and Jupiter. NASA's Dawn spacecraft circled Vesta from July 16, 2011 until September 5, 2012. When it departed and began its journey to dwarf planet Ceres. The giant asteroid is almost spherical and so is nearly classified a dwarf planet. Unlike most known asteroids, Vesta has separated into crust, mantle and core, a characteristic known as being differentiated much like Earth. Understanding why this is so was one of the objectives of the Dawn mission. The answer turned out to be that Vesta formed early, within 1 to 2 million years of the birth of the solar system. Short-lived radioactive material that was incorporated into bodies that formed during this epoch heated them to the point where, in cases like Vesta, the objects melted, allowing the denser material to sink to the asteroid's core and the lower density materials to use. Vesta has one of the largest brightness ranges observed on any rocky body in our solar system. The bright materials appear to be native rocks, while the dark material is believed to have been deposited by other asteroids crashing into Vesta. Scientists on the Dawn team estimate that about 300 dark asteroids with diameters ranging from 1 to 10 kilometers, 0.6 to 6 miles in Vesta during the last 3.5 billion years. This would have been enough to wrap the Vesta in a blanket of material about 3 to 7 feet, 1 to 2 meters thick. An extensive system of troughs encircles Vesta's equatorial region. The largest, named Divalia Fossa, is bigger than the Grand Canyon. Vesta appears to be the source of the Howardite, Eucrite and Diogentite groups of meteorites that have been found on Earth. They help scientists understand the lunar cataclysm when a repositioning of the gas giant planets billions of years ago established the orbits of asteroids in the early asteroid belt and triggered a solar system wide bombardment. They also provide clues in Vesta's geochemical evolution, a story that was tested and enhanced by the information Dawn provided about the asteroid's surface and interior. Vesta is believed to have lost about 1% of its mass less than a billion years ago in a massive collision responsible for the Silva crater, which is about 310 miles, 500 kilometers wide, some 95% of the asteroid's mean diameter. The Vesta family of asteroids is probably debris from this collision. Another huge crater is Venenia, which is about 250 miles, 400 kilometers in diameter. Discovery. Vesta was discovered at Bremen, Germany on March 29, 1807 by Heinrich William Alberts, who had previously discovered Pallas. He proposed incorrectly, as it turned out that Ceres and Pallas were fragments of a destroyed planet, and found Vesta as the search for more such objects. Vesta was the fourth asteroid ever to be discovered. How Vesta got its name? For Vesta's discoverer Heinrich William Alberts gave the honor of naming the new asteroid to German mathematician Carl Friedrich Gauss, who had computed its orbit. Gauss named it Vesta after the goddess of the hearth and household in Roman mythology. In fact, no matter what, for Vesta could not become a full-fledged planet due to Jupiter's gravity. So Ceres, the largest body in the asteroid belt, also became a dwarf. The largest in the asteroid belt, which is Ceres dwarf planet, earlier probably was asteroid planet. Now the group of dwarf planets, earlier probably was asteroid planet. Now the group of dwarf planets, the largest in the asteroid belt, which is Ceres dwarf planet, earlier probably was asteroid planet. Now the group of dwarf planets, earlier probably was asteroid planet. Now the group of dwarf planets, the only one in the asteroid belt. The other is Vesta, much smaller. Water like earth water, the most famous of the five dwarfs. Water like other earth water, the most famous of the five dwarfs. The only one in the asteroid belt. The other is Vesta, much smaller. Water like earth water, the most famous of the five dwarfs. Water like earth water, the most famous of the five dwarfs. The largest in the asteroid belt, which is Ceres dwarf planet. Earlier probably was asteroid planet. Now the group of dwarf planets. Earlier probably was asteroid planet. Now the group of dwarf planets. The largest in the asteroid belt, which is Ceres dwarf planet. Earlier probably was asteroid belt planet. Now the group of dwarf planets. Earlier probably was asteroid planets. Now the group of dwarf planets. After the terrestrial planets, orbit is in the asteroid belt, orbits around the sun, whose orbit is elliptical, orbits around the sun, whose orbit is elliptical. After the terrestrial planets, orbit is in the asteroid belt, orbit around the sun, whose orbit is elliptical, orbits around the sun, whose orbit is elliptical. The largest in the asteroid belt, which is Ceres dwarf planet. Earlier probably was asteroid belt. Now the group of dwarf planets. Earlier probably was asteroid planet. Now the group of dwarf planets. The largest in the asteroid belt, which is Ceres dwarf planet. Earlier probably was asteroid planet. Now the group of dwarf planets. Earlier probably was asteroid planet. Now the group of dwarf planets. By the way, the largest body in the asteroid belt is the dwarf planet Ceres, which is the most distant of the five dwarf planets. Is the orbit of Ceres elliptical? Yes, Ceres orbit around the sun is elliptical. Shape Ceres' orbit is elliptical with its closest point to the sun called perihelion and its farthest plane point called aphelion. Distance. Ceres' orbit ranges from 2.55 astronomical units IAU at perihelion to 2.98 AU at aphelion. Period. Ceres' orbital period, or the time it takes to complete one revolution, is about 4.6 Earth year tilt. Ceres' orbit is moderately tilted at 10.6 degree relative to the plane of Earth's orbit. Axial tilt. Ceres' axial tilt is 4 degree, which is close enough to 0 to result in minimal seasonal variations. Ceres is the largest asteroid and is located in the asteroid belt between the orbits of Mars and Jupiter. It has a flattened sphere shape with an equatorial radius of 490 km and a polar radius of 455 km. Ceres curiosities, the mysterious world comes into view. NASA Jet Propulsion Laboratory.government. HTTPS www.jpl.nasa.government. Blog 2014-12. Ceres curiosity. 29 December 2014. It is unknown whether, for example, it depends on solar heating and hence where Ceres is in its somewhat elliptical. Ceres facts. NASA Science.government. HTTPS science.nasa.government. Dwarf planets. Ceres facts. Orbit and rotation. Ceres takes 1.682 Earth days or 4.6 Earth years to make one trip around the Sun. As Ceres orbits the Sun, it completes one rotation every 9 hours, making its day length one of the shortest in the solar system. Ceres' axis of rotation is tilted just 4 degrees with respect to the plane of its orbit around the sun. That means it spins nearly perfectly upright and does not experience seasons like other more tilted planets do. Formation: Ceres formed along with the rest of the solar system about 4.5 billion years ago when gravity pulled swirling gas and dust into become a small dwarf planet. Scientists describe Ceres as an embryonic planet, which means it started to form but did not quite finish. Nearby Jupiter's strong gravity prevented it from becoming a fully formed planet. About 4 billion years ago, Ceres settled into its current location among the leftover pieces of planetary formation in the asteroid belt between Mars and Jupiter. Structure: Ceres is more similar to the terrestrial planets Mercury, Venus, Earth, and Mars than its asteroid neighbors, but it is much less dense. One of the similarities is a layered interior, but Ceres layers are not as clearly defined. Ceres probably has a solid core and a mantle made of water ice. In fact, Ceres could be composed of as much as 25% water. If that is correct, Ceres has more water than Earth does. Ceres' crust is rocky and dusty with large salt deposits. The salt on Ceres are not like table salt, sodium chloride, but instead we made of different minerals like magnesium sulfide. The largest in the asteroid belt, which is Ceres dwarf planet, earlier probably was asteroid planet. Now the group of dwarf planets, earlier probably was asteroid planet. Now the group of dwarf planets, the largest in the asteroid belt, which is Ceres dwarf planet, earlier probably was asteroid planet. Now the group of dwarf planets, earlier probably was asteroid planet. Now the group of dwarf planets, the only one in the asteroid belt. The other is based much smaller. Water like earth water, the most famous of the five door. Water like other earth water, the most famous of the five door. The only one in the asteroid belt. The other is based much smaller. Water like earth water, the most famous of the five door. Water like earth water, the most famous of the five door. The largest in the asteroid belt, which is Ceres dwarf planet. Earlier probably was asteroid planet. Now the group of dwarf planets. Earlier probably was asteroid planet. Now the group of dwarf planets. The largest in the asteroid belt, which is Ceres dwarf planet. Earlier probably was asteroid belt planet. Now the group of dwarf planets. Earlier probably was asteroid planets. Now the group of dwarf planets. After the terrestrial planets, orbit is in the asteroid belt. Orbits around the sun, whose orbit is elliptical. Orbits around the sun, whose orbit is elliptical. After the terrestrial planets, orbit is in the asteroid belt. Orbit around the sun, whose orbit is elliptical. orbits around the sun, whose orbit is elliptical. The largest in the asteroid belt, which is Ceres dwarf planet. Earlier probably was asteroid belt. Now the group of dwarf planets. Earlier probably was the asteroid planet. Now the group of dwarf planets. The largest in the asteroid belt, which is Ceres dwarf planet. Earlier probably was asteroid planet. Now the group of dwarf planets. Earlier probably was asteroid planet. Now the group of dwarf planets. Not only is Ceres bigger than Vesta, it is the largest dwarf planet in the entire asteroid belt. Is Ceres not as bright as Vesta? Yes, Ceres is not as bright as Vesta. Brightness, Vesta is the brightest asteroid visible from Earth, while Ceres is not. Vesta's visual magnitude is typical around 5.1, which makes it faintly visible to the naked eye. Ceres visual magnitude as 9.11, so it's best viewed with binoculars or a small telescope. Reflectivity, Vesta is more reflective than Ceres. Albedo, Vesta's albedo is 0.40 while Ceres albedo is 0.10. Albedo is a measure of how reflective a surface is. Distance from the sun, Vesta orbits closer to the sun than Ceres. Vesta's mean distance from the sun is 2.36 AU, while Ceres mean distance is 2.77 AU. Size, Ceres is nearly twice as large as Vesta. Ceres has a diameter of 585 miles, 940 kilometers, while Vesta has a diameter of 329 miles, 530 kilometers. Vesta and Ceres, what we knew about these worlds before. NASA, the government, HDBS solar system, NASA, government, news, Vesta and Ceres world. 16 August 2018. During its decade-long journey, Dawn has observed planet-like worlds, Vesta and Ceres, collecting detailed data about the two fascinating bodies in the main asteroid belt. Initial data from ground-based telescopes and NASA's Hubble Space Telescope provided some information about what we might find at the two bodies, though they had never been explored up close until dawn. The high resolution data Dawn has collected offer a clearer picture of the geologies of Vesta and Ceres, providing great insight into their histories. Here we briefly explore how Dawn has shaped and changed our understanding of these distant worlds. Whereas Dawn's observations at Vesta generally supported exciting existing hypotheses, providing greater detail to fill in the gaps less was known about Ceres. In fact, most of what we know about the dwarf planet was contributed by Dawn. Initial calculations suggested that Ceres might be differentiated into layers. Though before Dawn, the composition of these layers was unknown. With a low average density, Ceres was expected to have large amounts of water ice beneath its surface. Distant observations also showed Ceres to have a relatively smooth surface. Dawn complicated this picture. Gravity data confirmed that Ceres is in fact differentiated into a rocky core and a water ice crust covered by a dusty outer layer. Dawn also found evidence of clathrate hydrates, a gas trapped within a crystal structure of water molecules, which contribute to the remarkable strains and low density of Ceres crust. While most of Ceres is relatively smooth due to its semi-fluid subsurface ice layer. Dawn did find one large mountain that hadn't been seen before, around 2.5 miles, 4 kilometers high. This mountain, called Ahuna Mons, is almost as high as Mount Whitney in California. Its well-defined domed shape, similar to volcanoes on Earth, suggests that it likely formed due to cryovolcanic activity. That is, when muddy ice was expelled from Ceres interior and froze on its surface. Though cryovolcanism was hypothesized on Ceres and may be present on other icy worlds, Dawn's observations make Ahuna Mons the closest known cryovolcano in the solar system. Ahuna Mons is also evidence of recent geological activity within the past 100 million years of or less, making Ceres one of a few bodies in the solar system that show signs of recent activity. Hubble's images showed evidence of several brighter areas on Ceres' surface when Dawn took a closer look, finding hundreds more than the initial images had captured. Scientists hypothesized about what these bright spots might be as Dawn moved into lower orbits. It became clear that these spots were actually salt deposits likely left behind when briny water escaped from below Ceres' surface and sublimated limited away. Other observations taken by the European Space Agency's Herschel Space Observatory showed a small amount of water vapor around parts of Ceres, leading some scientists to hypothesize that it may have a weak atmosphere or even ongoing cryovolcanic activity. Dawn discovered that this gas might be produced by energetic particles from the sun colliding with water ice on Ceres, which is then released as vapor, resulting in a temporary weak atmosphere. Dawn's spectroscopic data also confirmed the presence of ammonia on Ceres' surface, which had been suggested from telescopic observations in the 1990s. Conditions in the main asteroid belt should have been too warm for ammonia, which requires much colder conditions to form, raising questions about its origins. Ceres may have formed further into the colder outer solar system before migrating to its current position, or ammonia could have been brought to Ceres by bodies from the outer solar system, complicating previous ideas about Ceres history. Dawn also confirmed the presence of carbonates on Ceres, which had been detected a decade earlier in telescopic data. Carbonates, which generally form in warm liquid, are often found in meteorites believed to come from asteroids formed with a large amount of water. Dawn's detection of a variety of carbonates on Ceres further supports the existence of a large ocean in Ceres' early history. Ceres may even be warm enough to have a small amount of remaining liquid water underground. This potential for liquid water, in combination with the organics that Dawn found in unearthed crater, makes Ceres interesting to those who study the chemistry that leads to the formation of life. While Dawn has answered many questions about Vesta and Ceres, its findings have also raised many questions that Dawn alone cannot answer. Though Dawn will end, its accomplishments and findings will continue to inform future study of these two worlds. The inner ring of with the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his places up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. Trojan's arrow cut toward the satellite. Someone who did not live with the sun. Kuiper belt is like the asteroid belt. Arrow cut is the hammer from there. Kuiper belt is like the asteroid belt. Arrow cut is the hammer from there. Trojan's arrow cut toward satellite. Someone who did not leave the sun. Kuiper belt is like the asteroid belt. Arrow cut is the hammer from there. Kuiper belt is like the asteroid belt. Arrow cut is the hammer from there. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. Comets are included in the asteroid belt. trained to raid anywhere. Meteors form clouds there. Unknown risks may rain down. Meteors form clouds there. Unknown risks may rain there. Comets are included in the asteroid belt. Train to raid anywhere. Meteors form clouds there. Unknown risks may rain down. Meteors form clouds there. Unknown risks may rain down. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built is the palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. In the asteroid belt, Ceres is faint and Vesta is bright. Do Ceres and Vesta have different compositions? Yes, Ceres and Vesta have different compositions. Vesta, a rocky, dense terrestrial world with a metallic core, silicate mantle, and basaltic crust. Vesta was heated more than Ceres, which led to its differentiation. Ceres, a volatile, rich, rocky body with a rigid crust, less rigid interior, and solid core. Ceres experienced less heating than Vesta, which led to its differentiation into rock and ice. Ceres has a lower density than Vesta, indicating that ices are a major part of its composition. Here are some other differences between Ceres and Vesta. Hydrogen. Vesta's dark hemisphere has more hydrogen deposits than hydroxyl, indicating higher concentrations of hydrated minerals at depth. Ceres has dissimilar distributions of elemental hydrogen and hydrogen bearing species. Carbon. Ceres has high concentrations of carbon within its regolith. Ice. Ceres has subsurface ice as indicating by high concentrations of hydrogen in its polar regions. Ceres and Vesta have been instrumental in learning how inner solar system material formed and evolved. As mentioned, Ceres and Vesta have different compositions, densities and surface properties. Vesta and Ceres, what we knew about this world before. NASA.government, https solarsystem.nasa.government, news, Vesta and Ceres. 16 August 2018, Vesta. Before Dawn visited Vesta, the first stop on its interplanetary journey, scientists were able to make inference about what it might be like based on meteorites believed to be from Vesta and data from telescopes. Basalt in such meteorites suggested that it had a magmatic history. Such a hot history also implied that its interior would be differentiated into compositionally distinct layers based on density. Overall, Dawn was expected to find a dry, rocky world with a hot history in line with other terrestrial inner solar system bodies. These predictions were mostly correct, though Dawn's data revealed several unforeseen features. Images and Hubble captured its irregularly shaped southern hemisphere due to the colossal impact that formed Silva basin. Dawn's camera found that its southern hemisphere had been resurfaced by this collision, leaving it with far fewer craters than its northern hemisphere. Dawn also found through increased cling vistas equator that are concentric with its two giant basins, Silva and Venenia. The energy of the impact that formed these basins sent waves through Vesta's inner interior that created throws in order to form. These throws require internal layers that react differently to stress, supporting Vesta's hypothesized differentiation. Dawn's gravity data confirmed this hypothesis. Dawn also confirmed another hypothesis that Howardite Euclid Diogenic meteorites HED, a class of meteorites that makes up a whopping 6% of those found on Earth, originated at Vesta. These meteorites were originally present in different layers of Vesta's interior before being excavated and ejected into space by impacts like Silva's impacts are likely also responsible for bringing foreign material to Vesta's surface. Though Hubble had observed variation in Vesta's albedo surface reflectivity, Dawn found unexpectedly distinct dark patches. Their non-random distribution seems to indicate that they are the result of low energy impacts by carbon bearing asteroids that delivered the darker material to Vesta and other impacts that melted Vesta's surface, darkening the material there. Brighter material on Vesta's surface was likely exposed and scattered by impacts. Asteroids also delivered the unexpected hydrated material that Dawn found beyond craters and troughs. Dawn's lower orbits also offered views of a variety of surface features, including dramatic slopes and slides, which could not be seen from the distant telescopes before dawn. Overall, Dawn's data support many of the previous hypotheses about Vesta, while illuminating Vesta's striking features and revealing unexpected process. Between Jovian and terrestrial, there is an important ring oval. This is the asteroid belt. This is the unique wonder of the solar system. This is the asteroid belt. This is the unique wonder of the solar system. Between Jovian and terrestrial, there is an important ring oval. This is the asteroid belt. This is the unique wonder of the solar system. This is the asteroid belt. This is the unique wonder of the solar system. Icy is just like Jovian. It is rocky like terrestrial. Roll up with the bodies in the belt. The strange story of the solar system. Roll up with the bodies in the belt. The strange story of the solar system. Icy is just like Jovian. It is rocky like terrestrial. Roll up with the bodies in the belt. The strange story of the solar system. Roll up with the bodies in the belt. The strange story of the solar system. Between Jovian and terrestrial, there is an important ring oval. This is the asteroid belt. This is the unique wonder of the solar system. This is the asteroid belt. This is the unique wonder of the solar system. Between Jovian and terrestrial, there is an important ring oval. This is the asteroid belt. This is the unique wonder of the solar system. This is the asteroid belt. This is the unique wonder of the solar system. There are billions of asteroids in the belt. Sometimes the fights are also formed. Dust increases in the rings. Perhaps smoky clouds also increase. Dust increases in the rings. Perhaps smoke clouds also increase. There are billions of asteroids in the belt. Sometimes the fights are also formed. Dust increases in the rings. Perhaps smoke clouds also increase. Dust increases in the rings. Perhaps smoke clouds also increase. Between Jovian and terrestrial, there is an important ring oval. This is the asteroid belt. This is the unique wonder of the solar system. This is the asteroid belt. This is the unique wonder of the solar system. Between Jovian and terrestrial, there is an important ring oval. This is the asteroid belt. This is the unique wonder of the solar system. This is the asteroid belt. This is the unique wonder of the solar system. The asteroid belt is like a ring, a thin belt like a ring, where billions of small and large objects are revolving around the sun and are always colliding. Is there a smoke-like cloud in the asteroid belt? What is meteor smoke? Teeny meteors leave smoke in the atmosphere. NASA's studying produced when asteroids collide or comets are vaporized by the sun. Some of the material burns up when it enters the atmosphere, just like the Geminids, but on a much smaller scale. About 55 miles above Earth, the minuscule fireballs leave a puff of even tinier particles called meteoric smoke. 13 December 2021. Meteor smoke makes strange clouds. NASA.government. HTTPS www.nasa.government. Missions aim meteor smoke 2 August 2012. Anyone who's ever seen a noctilucent cloud or NLC would agree they look alien. The electric blue ripples and pale tendrils of NLCs reaching across the night sky resemble something from another world. Researchers say that's not far off. A key ingredient for the mysterious clouds comets comes from outer space. We have detected bits of meteor smoke embedded in noctilucent clouds, reports James Russell of Hampton University, principal investigator of NASA's AIM mission to study the phenomenon. This discovery supports the theory that meteor dust is the in nucleating agent around which NLCs form. Noctilucent clouds are a mystery dating back to the late 19th century. Northern sky watchers first noticed them in 1885, about 2 years after the eruption of Krakatoa. Ash from the Indonesian volcano caused such splendid sunsets that evening sky watching became a worldwide pastime. One observer, in particular a German named T.W. Backhaus, who is often credited with the discovery of NLCs, noticed something odd. He says stays outside longer than most people, long enough for the twilight to fully darken, and on some nights he saw wispy filaments glowing electric blue against the black sky. Scientists of the day figured they were some manifestation of volcanic dust. Eventually, Krakatoa's ash settled and the sunset faded, but strangely the noctilucent clouds did not go away. They are still present today, stronger than ever. Researchers are not sure what role Krakatoa's ash played in those early sightings. One thing is clear, however, the dust behind the clouds we see now is base dust. Mark Harbing of the company GATS Inc. led the team that found the extraterrestrial connection using AIM's solar occultation for the eyes experiment SOFIE. We found that about 3% of each ice crystal in a noctilucent cloud is meteoritic, says Harbing. The inner solar system is littered with meteorites of all shapes and sizes, from asteroid-sized chunks of rock to microscopic specks of dust. Every day Earth scopes of tons of the material, mostly the small stuff. When meteorites hit our atmosphere and burn up, they leave behind a haze of tiny particles suspended 70 km to 100 km above Earth's surface. It's no coincidence that NLCs form 83 km high squarely inside the meteor smoke zone. Specks of meteor Smoke acts as gathering point where water molecules can assemble themselves into ice crystals. The process is called nucleation. Nucleation happens all the time in the lower atmosphere in ordinary clouds, airborne specks of dust, and even living microbes can serve as nucleation sites. Tiny ice crystals, drops of water, and snowflakes grow around these particles, falling to each earth if and when they become heavy enough. Nucleating agents are especially important in the ethereal realm of analysis. The clouds form at the edge of space where the air pressure is little more than vacuum. The odds of two water molecules meeting is slim and of striking together slimmer still. Meteor smoke helps beat the odds. According AIM data, ice crystals can grow around meteoritic dust to sizes ranging from 20 to 70 nanometers. For compression, cirrus clouds in the lower atmosphere where water is abundant contain crystals 10 to 100 times larger. The small size of the ice crystals explains the cloud's blue color. Small particles tend to scatter short wavelengths of light blue more strongly than long wavelengths red. So when a beam of sunlight hits an NLC, blue is the color that gets scattered down to earth. Meteor smoke explains much about NLCs, but a key mystery remains. Why are the clouds brightening and spreading? In the 19th century, NLCs were confined to high latitude places like Canada and Scandinavia. In recent times, however, they have been spotted as far south as Colorado, Utah, and Nebraska. The reason Russell believes is climate change, one of the greenhouse gases that has become more abundant in Earth's atmosphere since the 19th century is methane. It comes from landfills, natural gas and petroleum system, agriculture activities and coal mining. It turns out that methane boosts NLCs. Russell explains when methane makes its way into the upper atmosphere, it is oxidized by a complex series of reactions to form water vapor. This extra water vapor is then available to grow ice crystals for NLCs. If this idea is correct, noctilucent clouds are a sort of canary in a coal mine for one of the most important greenhouse gases, and that, says Russell, is a great reason to study them. Noctilucent clouds might look alien, but they are telling us something very important about our own planet. Between Jovian and terrestrial, there is an important ring oval. This is the asteroid belt. This is the unique wonder of the solar system. This is the asteroid belt. This is the unique wonder of the solar system. Between Jovian and terrestrial, there is an important ring oval. This is the asteroid belt. This is the unique wonder of the solar system. This is the asteroid belt. This is the unique wonder of the solar system. Icy is just like Jovian. It is rocky like terrestrial. Roll up with the bodies in the belt. The strange story of the solar system. Roll up with the bodies in the belt. The strange story of the solar system. Icy is just like Jovian. It is rocky like terrestrial. Roll up with the bodies in the belt. The strange story of the solar system. Roll up with the bodies in the belt. The strange story of the solar system. Between Jovian and terrestrial, there is an important ring oval. This is the asteroid belt. This is the unique wonder of the solar system. This is the asteroid belt. This is the unique wonder of the solar system. Between Jovian and terrestrial, there is an important ring oval. This is the asteroid belt. This is the unique wonder of the solar system. This is the asteroid belt. This is the unique wonder of the solar system. There are billions of asteroids in the belt. Sometimes fights are also formed. Dust increases in the rings. Perhaps smoky clouds also increase. Dust increases in the rings. Perhaps smoke clouds also increase. There are billions of asteroids in the belt. Sometimes fights are also formed. Dust increases in the rings. Perhaps smoke clouds also increase. Dust increases in the rings. Perhaps smoke clouds also increase. Between Jovian and terrestrial, there is an important ring oval. This is the asteroid belt. This is the unique wonder of the solar system. This is the asteroid belt. This is the unique wonder of the solar system. Between Jovian and terrestrial, there is an important ring oval. This is the asteroid belt. This is the unique wonder of the solar system. This is the asteroid belt. This is the unique wonder of the solar system. Both Ceres and Vesta reside in the asteroid belt between the Jovian and terrestrial planets. Mercury, Venus, Earth, Mars are terrestrial planets. Why are Jupiter, Saturn, Uranus and Neptune called Jovian? Jupiter, Saturn, Uranus and Neptune are called Jovian planets because they are similar to Jupiter, which is the largest planet in our solar system and is also known as Jove in Roman mythology. Size. The Jovian planets are much larger than Earth. Jupiter is 318 times the mass of Earth and Neptune is 17 times the mass of Earth. Composition. The Jovian planets are mostly made of hydrogen and helium with some other gases and ices. They are also known as gas giants because they don't have a solid surface like Earth. Location. The Jovian planets are located beyond the asteroid belt on the outskirts of our solar system. The term Jovian is also used to describe Jupiter mass exoplanets found outside of our solar system. The Jovian planets. NASA Science.Government, HTTPS, SMD, CMS, NASA.Government uploads 2023-7 PDF. The Jovian planets. These images of the four Jovian planets, Jupiter, Saturn, Uranus and Neptune, hint at some of the remarkable attributes that set them apart from the smaller rocky terrestrial planets, also called giant planets. The Jovian planets occupy orbits in the outer solar system at distances ranging from 5 Jupiter to 30 Neptune times the Earth's distance from the Sun. Unlike the terrestrial planets that make up our inner solar system, Mercury, Venus, Earth and Mars, the Jovian planets do not have solid surfaces. Instead, they are composed primarily of hydrogen and helium with traces of methane, ammonia, water and other gases in their atmospheres. These gases make up a deep atmosphere and become tightly compressed around relatively teeny cores of rock. At great depths within Jupiter, for example, the hydrogen gas is compacted so tightly that it exists in a rare metallic form. Each of the Jovian planets has several characteristics in common. While Saturn's bright rings are the most visible and well-known, fainter and darker rings have been seen around Jupiter, Uranus and Neptune. The Jovian planets also are distinctive for having many moons. Saturn and Jupiter each have more than 60 moons. Uranus has more than 20 and Neptune has more than 10. The planets also have fierce winds and storms and a rapid rotation. When compared to Earth, the Jovian planets are enormous. Jupiter is 11 times larger than Earth in diameter and is the biggest planet in our solar system. Saturn is the next largest at 9 times bigger than Earth. Uranus and Neptune are both roughly 4 times larger than Earth. Despite their size, the Jovian planets have low densities because of their gaseous composition. Saturn, for example, is made of materials lighter than water. If it could be placed in a giant swimming pool, the planet would float. The Jovian planets' colors differ due to their temperature, composition and cloud height. For example, the brown clouds on Jupiter are deeper in the atmosphere than the planet's white ammonia clouds. Neptune's pink-white methane ice clouds are higher in the atmosphere than its blue gaseous atmosphere. Surprisingly, it is the trace gases in the Jovian atmospheres, not the hydrogen or helium, that give the planet's clouds their color. For example, Uranus and Neptune are blue-green because they have a small amount of methane in their upper atmosphere. Vocabulary, density, the amount of mass per volume in an object or region of space. National Aeronautics and Space Administration, Goddard Space Flight Center, 8800 Greenbelt Road, Greenbelt, Maryland, 20771, www.nasa.government. The inner ring of the solar system, what havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his places up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. Frozen's arrow cut over satellite. Someone who did not live with the sun. Kuiper belt is like the asteroid belt. Arrow cut is the hammer from there. Kuiper belt is like the asteroid belt. Arrow cut is the hammer from there. Frozen's arrow cut over satellite. Someone who did not leave the sun. Kuiper belt is like the asteroid belt. Arrow cut is the hammer from there. Kuiper belt is like the asteroid belt. Arrow cut is the hammer from there. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. Comets are included in the asteroid belt. Trained to raid anywhere. Meteors form clouds there. Unknown risks may rain down. Meteors form clouds there. Unknown risks may rain there. Comets are included in the asteroid belt. Trained to raid anywhere. Meteors form clouds there. Unknown risks may rain down. Meteors form clouds there. Unknown risks may rain down. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. What is the difference in distance between terrestrial planets and Jovian planets? The main difference in distance between terrestrial planets and Jovian planets is that terrestrial planets are closer to the sun while Jovian planets are further away. Terrestrial planets. These planets are within 1 astronomical unit, AU, of the sun. 1 AU is the distance from Earth to the sun. Jovian planets. These planets are further away from the sun, ranging from 5 to 30 AU from the sun. There are some other differences between terrestrial and Jovian planets. Size. Jovian planets are much larger than terrestrial planets, up to 11 times the size of Earth. Composition. Terrestrial planets are made of rock and metal, while Jovian planets have a rocky core with metallic liquid and gaseous hydrogen and helium density. Terrestrial planets are up to 9 times denser than Jovian planets. Speed. Terrestrial planets move faster than Jovian planets because they are closer to the sun and have a shorter distance to travel when orbiting. The four terrestrial planets are the planets closest to the sun, while the four Jovian planets are the planets farthest from the sun. The Jovian planets are also known as giant planets. Distance. Terrestrial planets are 1 AU or less from the sun. Jovian planets extend to 30 AU from the sun. Size. Jovian planets are more massive than the terrestrial planets, up to 11 times the size of Earth. Chapter 1, the solar system, NASA Science.Government, HTTPS science.nasa.government. Learn basics of space flight. The terrestrial planets, the planets Mercury, Venus, Earth and Mars are called terrestrial because they have a compact rocky surface like Earth's terra firma. The terrestrial planets are the four innermost planets in the solar system. None of the terrestrial planets have rings, although Earth does have belts of trapped radiation as discussed below. Among the terrestrials, only Earth has a substantial planetary magnetic field. Mars and the Earth's moon have localized regional magnetic field at different places across their surfaces, but no global field. Of the terrestrial planets, Venus, Earth and Mars have significant atmospheres. The gases present in a planetary atmosphere are related to a planet's size, mass, temperature, how the planet was formed and whether life is present. The temperature of gases may cause their molecules of atoms to achieve velocities that escape the planet's gravitational field. This contributes to Mercury's lack of a permanent atmosphere, as does its proximity to the source of the relentless solar wind. The presence of the life on Earth causes oxygen to be abundant in the atmosphere, and in this Earth is unique in our solar system. Without life, most of the oxygen would soon become part of the compounds on the planet's surface. Thus, the discovery of oxygen's signature in the atmosphere of Earth's extrasolar planet would be significant. Asteroid. Though there are several named groups of asteroids which are covered in the next section, the term asteroid has increasingly come to particularly refer to the small rocky and metallic bodies of the inner solar system out to the orbit of Jupiter. Millions of main belt asteroids orbit the Sun, mostly between Mars and Jupiter. Asteroids are also called minor planets. The Jovian planets. Jupiter, Saturn, Uranus and Neptune are known as the Jovian, Jupiter-like planets because they are all gigantic compared with Earth, and they have a gaseous nature like Jupiter's, mostly hydrogen with some helium and trace gases and ices. The Jovian planets are thus referred to as the gas giants because gas is what they are mostly made of, although some or all of them probably have small solid cores. All have significant planetary magnetic fields, rings, and lots of satellites. Whatever the difference between Jovian and terrestrial, Jupiter is the one that has caused a lot of wealth in the asteroid belt. Jupiter stopped Ceres with its strong gravitational force. Jupiter blocks Ceres, did not let another planet form. Ceres is still like an embryo. The asteroid belt lost its way. Ceres is still like an embryo. The asteroid belt lost its way. Jupiter blocks Ceres, did not let another planet form. Ceres is still like an embryo. The asteroid belt lost its way. Ceres is still like an embryo. The asteroid belt lost its way. Neptune is the pride of the Kuiper belt. Ceres could not build up its pride. Ceres is a dwarf in the asteroid belt. Did not get the honor of being a planet. Ceres is a dwarf in the asteroid belt. Did not get the honor of being a planet. Neptune is the pride of the Kuiper belt. Ceres could not build up its pride. Ceres is a dwarf in the asteroid belt. Did not get the honor of being a planet. Ceres is a dwarf in the asteroid belt. Did not get the honor of being a planet. Jupiter blocks Ceres, did not let another planet form. Ceres is still like an embryo. The asteroid belt lost its way. Ceres is still like an embryo. The asteroid belt lost its way. Jupiter blocks Ceres, did not let another planet form. Ceres is still like an embryo. The asteroid belt lost its way. Ceres is still like an embryo. The asteroid belt lost its way. Use the force of Jupiter. Break only the arrangement. Ceres could not get back together. Today Ceres is known as a Dover. Ceres could not get back together. Today Ceres is known as a Dover. He used the force of Jupiter, break only the arrangement. Ceres could not get back together. Today Ceres is known as a Dover. Ceres could not get back together. Today Ceres is known as a Dover. Jupiter blocks Ceres, did not let another planet form. Ceres is still like an embryo. The asteroid belt lost its way. Ceres is still like an embryo. The asteroid belt lost its way. Jupiter blocks Ceres, did not let another planet form. Ceres is still like an embryo. The asteroid belt lost its way. Ceres is still like an embryo. The asteroid belt lost its way. Ceres is a very large asteroid in the asteroid belt. NASA says that Ceres is the same today as it was 4 billion years ago. NASA also says that Ceres stopped short of becoming a planet. That is why NASA says that Ceres is like a planetary embryo. Can embryos come into existence even later? Even late? Can Ceres ever become a planet? No. Ceres is not likely to become a planet because it does not meet the requirements to be classified as one. Orbit. Ceres shares its orbit with thousands of other asteroids in the asteroid belt and only makes up about 40% of the belt's total mass. The mass of the asteroid belt is estimated to be about 4% of the mass of the moon. So, any object formed from that mass only would not be a planet. The dwarf planet Ceres. Ceres is the largest object in the asteroid belt and is classified as a dwarf planet. It's a ball of rock and ice with a diameter of 592 miles, 953 kilometers. Here's some more information about Ceres. Ceres was discovered in 1801 and was initially thought to be a planet. It was reclassified as an asteroid when it was determined to be too small. In 2006, Ceres was reclassified as a dwarf planet after the discovery of Eris, which raised questions about how to define planets and other objects. Ceres, many have failed to gather enough building blocks to become a planet. Scientists have found signs of a large subsurface body of briny liquid beneath the ice on Ceres. Ceres facts, NASA science.government, https science.nasa.government, dwarf planet Ceres facts. Ceres is the only dwarf planet in the inner solar system. It was the first dwarf planet to receive a visit from a spacecraft. Introduction. Dwarf planet Ceres is the largest object in the asteroid belt between Mars and Jupiter, and it's the only dwarf planet located in the inner solar system. It was the first member of the asteroid belt to be discovered when Giuseppe Piaggi spotted it in 1801. When NASA's Dawn arrived in 2015, Ceres became the first dwarf planet to receive a visit from a spacecraft. Called an asteroid for many years, Ceres is so much bigger and so different from its rocky neighbors that scientists classified it as a dwarf planet in 2006. Even though Ceres comprises 25% of the asteroid belt's total mass, Pluto is still 14 times more massive formation. Ceres formed along with the rest of the solar system about 4.5 billion years ago, when gravity pulled swirling gas and dust in to become a small dwarf planet. Scientists describe Ceres as an embryonic planet, which means it started to form but did not quite finish. Nearby Jupiter's strong gravity prevented it from becoming a fully formed planet. About 4 billion years ago, Ceres settled into its current location among the leftover pieces of planetary formation in the asteroid belt between Mars and Jupiter. Jupiter blocks Ceres, did not let another planet form. Ceres is still like an embryo. The asteroid belt lost its way. Ceres is still like an embryo. The asteroid belt lost its way. Jupiter blocks Ceres, did not let another planet form. Ceres is still like an embryo. The asteroid belt lost its way. Ceres is still like an embryo. The asteroid belt lost its way. Neptune is the pride of the Kuiper belt. Ceres could not build up its pride. Ceres is a dwarf in the asteroid belt. Did not get the honor of being a planet. Ceres is a dwarf in the asteroid belt. Did not get the honor of being a planet. Neptune is the pride of the Kuiper belt. Ceres could not build up its pride. Ceres is a dwarf in the asteroid belt. Did not get the honor of being a planet. Ceres is a dwarf in the asteroid belt. Did not get the honor of being a planet. Jupiter blocks Ceres, did not let another planet form. Ceres is still like an embryo. The asteroid belt lost its way. Ceres is still like an embryo. The asteroid belt lost its way. Jupiter blocks Ceres, did not let another planet form. Ceres is still like an embryo. The asteroid belt lost its way. Ceres is still like an embryo. The asteroid belt lost its way. Use the force of Jupiter. Wrecked only the arrangement. Ceres could not get back together. Today Ceres is known as a dover. Ceres could not get back together. Today Ceres is known as a dover. He used the force of Jupiter, wrecked only the arrangement. Ceres could not get back together. Today Ceres is known as a dover. Ceres could not get back together. Today Ceres is known as a dover. Jupiter blocks Ceres, did not let another planet form. Ceres is still like an embryo. The asteroid belt lost its way. Ceres is still like an embryo. The asteroid belt lost its way. Jupiter blocks Ceres, did not let another planet form. Ceres is still like an embryo. The asteroid belt lost its way. Ceres is still like an embryo. The asteroid belt lost its way. The dwarf planet Ceres in the asteroid belt actually could not attain planetary status because of Jupiter's gravitational force. Can the gravitational force of a giant planet hinder planet formation? This suggests that the gravitational influence of an outer gas giant actually facilitates the formation of massive terrestrial planets by affecting the interactions between planetesimals and planetary embryos in the terrestrial planet zone. Giant planet effects on terrestrial planet formation and system. Oxford Academic HTTPS academic.oup.com Amenadas article by AC Childs 2019 cited by 22. Using an updated collision model, we conduct a suite of high resolution in body integrations to probe the relationship between giant planet mass and terrestrial planet formation and system architecture. We vary the mass of the planets that reside at Jupiter's and Saturn's orbit and examine the effects on the interior terrestrial system. We find that massive giant planets are more likely to eject material from the outer edge of the terrestrial disk and produce terrestrial planets that are on smaller, more circular orbits. We do not find a strong correlation between exterior giant planet mass and the number of Earth analogous in mass and semi-major axis produced in the system. These results allow us to make predictions on the nature of terrestrial planets orbiting distant sun-like star systems that harbor giant planet companions on long orbits, system that will be a priority for NASA's upcoming Wide Field Infrared Survey Telescope WFIRST mission. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his places up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. Trojan's arrow cut toward the satellite. Someone who did not live with the sun. Kuiper belt is like the asteroid belt. Arrow caught is the hammer from there. Kuiper belt is like the asteroid belt. Arrow caught is the hammer from there. Trojan's arrow cut toward satellite. Someone who did not leave the sun. Kuiper belt is like the asteroid belt. Arrow caught is the hammer from there. Kuiper belt is like the asteroid belt. Arrow caught is the hammer from there. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. Comets are included in the asteroid belt. Trained to raid anywhere. Meteors form clouds there. Unknown risks may rain down. Meteors form clouds there. Unknown risks may rain there. Comets are included in the asteroid belt. Trained to raid anywhere. Meteors form clouds there. Unknown risks may rain down. Meteors form clouds there. Unknown risks may rain down. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. The inner ring of the solar system. What havoc did the asteroid belt create? Every planet is attacked by asteroids. Built his palace up to 80 planets. Every planet is attacked by asteroids. Built his palace up to 80 planets. Is the dwarf planet Ceres the embryo of a planet? Yes, Ceres is considered an embryonic planet because it started to form but don't finish. Formation. Ceres formed around 4.5 billion years ago along with the rest of the solar system. It was created when gravity pulled in swirling gas and dust. Prevention. Jupiter's strong gravity prevented Ceres from becoming a fully formed planet. Location. Ceres settled into its current location in the asteroid belt between Mars and Jupiter around 4 billion years ago. Size. Ceres is 590 miles, 950 kilometers in diameter, which is about the size of Texas. Composition. Ceres has an icy mantle and a solid core with up to 25% of its composition being water. Features. Ceres has craters, tectonic features and cryovolcanism temperature. On Ceres, dayside temperature range from minus 136 to minus 28 degrees Fahrenheit, minus 32 to 33 degrees Celsius. At night temperature are around minus 225 Fahrenheit, minus 143 Celsius. Atmosphere. Ceres has no atmosphere. Ceres facts. NASA Science, NASA Science.government, HTTPS Science.nasa.government. Dwarf planet Ceres facts. Ceres formed along with the rest of the solar system about 4.5 billion years ago when gravity pulled swirling gas and dust in it into become a small dwarf planet. Scientists describe Ceres as an embryonic planet, which means it started to form but did not quite finish formation. Ceres formed strong along with the rest of the solar system about 4.5 billion years ago, when gravity pulled swirling gas and dust into become a small dwarf planet. Scientists describe Ceres as an embryonic planet, which means it started to form but did not quite finish. Nearby Jupiter's strong gravity prevented it from becoming a fully formed planet. About 4 billion years ago, Ceres settled into its current location among the leftover pieces of planetary formation in the asteroid belt between Mars and Jupiter. Structure: Ceres is more similar to the terrestrial planets Mercury, Venus, Earth, and Mars than its asteroid neighbors, but it is much less dense. One of the similarities is a layered interior, but Ceres layers are not as clearly defined. Ceres probably has a solid core and a mantle made of water ice. In fact, Ceres could be composed of as much as 25% water. If that is correct, Ceres has more water than Earth does. Ceres' crust is rocky and dusty with large salt deposits. The salts on Ceres are not like table salt, sodium chloride, but instead are made of different minerals like magnesium sulfate. Ceres is in the asteroid belt, which is located between the terrestrial and giant planets. Friends, I tried to write a lot about the asteroid belt. Whether this article of mine will have an impact in the future or not, you decide. Till then, allow me to write about our home planet Earth.